Hey everyone, I've gotten a few requests to kind of explain how I actually built this custom CD player inspired by the Biosound 9000. So I thought I would go through and kind of outline how I went about making this and kind of try to do it in one take quickly, go through everything. So really how this started was I saw an Instagram video of the Biosound 9000. I was like, that's just such a cool machine. And I'd love to try to build at least something that resembled it in some way, because I mean, I'm kind of becoming a bigger fan of physical media. And I mean, I've loved music like my entire life. And I've loved engineering and robotics. So this was a good blend of all of those things into one project. But basically what I did first was I just bought a couple of these $13 super cheap CD players off Amazon, and you can kind of just rip them apart and take out all of the electronics, and they're USB CD players. And basically what I did was I retrofitted all the CD reading electronics into this little I don't know what you call it, sandwich of electronics. And you can see inside I've kind of squished everything. Instead of being this big square layout like they have here, I've kind of just stacked it all on top of itself into this and just crammed it all in this little tiny 3D printed box. And once I got this into a more manageable form factor, I started printing a bunch of these, which are basically just little versions of one segment of the CD holders, so I could test the pickup system. And it went through a bunch of iterations. Like, this wasn't here originally, which is just a little cam system to hold the CDs down until they can be lifted out of this container. And then there's a bunch of iteration with like this little tiny dovetail, chamfer, whatever you want to call it, angle on the inside of the holder, which kind of pushes the CDs downwards once this cam pushes on them. And once I got that working, it was kind of smooth sailing through the rest of the project. It just took a lot of time to actually manufacture all of this. And I'm going to take off the front so I can kind of explain what I started doing next. Well, really what I started doing next was I went and I started CADing everything. So there's a 3D model of basically everything in this, because most of it's 3D printed. And then there's some aluminum parts that I had to cut, drill, all kinds of little things to fit them into here. But the bulk of what's going on is down in the bottom here. So it's basically just a DAC here, a Raspberry Pi 4 buried down here, a Raspberry Pi Pico here, a analog to digital converter for this potentiometer, which there's this big compound gear ratio here. It just basically just used to reduce this linear travel distance across the whole CD player into 270 degrees for this potentiometer to read, and then that goes to the analog to digital converter. And then I just printed this, or I didn't print it. I got it from PCBWay. This little printed circuit board. It's just a carrier board to hold all of this stuff, so I didn't have to have a massive rat's nest of wires, which I already kind of do. So it would have just been worse if I didn't do that. But it's just two NEMA 17 stepper motors, and the tilting mechanism is this motor. And basically it's just a small gear ratio here where this outer one is, and I'll spin it so you can see it better, is connected to the motor. And then there's a part of a ring gear, like a semicircle ring gear, and that was just because of space. And that goes down to a pulley, which is pretty hard to see, but let's see if I can make it easier to see with some light. It's not better. You can kind of see it down there, but the pulley goes all the way up to this tilter mechanism, and this basically just controls the CD player up and down tilt in each of the carriage positions. So you can see this spins, moves the ring gear, pulley all the way up to here, and then this huge hex shaft, and then a round shaft, which this is what the CD player is attached to in a little slot. And then that just lets this whole thing tilt up and down with that motor. And then the side-to-side movement is a lot simpler. It's just a motor directly attached to a pulley, and then the pulley just runs this big loop all the way across. And so, I mean, I guess I can go into the control system a little. All the movement and everything is controlled on the Pico. I could have done it all just on the Raspberry Pi, but I split it between the Pico and the Pi because it was just a little more convenient to write all the control stuff in C++ and then all of the UI stuff with Python and JavaScript and CSS. So I just split them, and then there's just a little micro USB they connect and then just talk over serial. And what next? I guess the pickup system, it's a little hard to see how this translates to this, but I have a off-cut version of this so you can see it a little bit better. This circle in the middle is actually a little indentation, so the clipping thing on the CD player actually sticks out a little bit more than the disc. So you have to have this little indent for that to slip in to actually push the disc on. So that is basically this piece. And then the rail system is just this metal rod pushed into a bunch of 3D prints that goes all the way down, so you have a smooth rail on the top and bottom for the carriage to slide along. And then the screen is just a cheap 7-inch Raspberry Pi screen off Amazon that I got. And in terms of power, it's a 24-volt power supply that goes through here, and that was just to give the max amount of power to these little stepper drivers to give to these motors. And then here's a buck converter here that runs it down to power the Raspberry Pi, the screen, the DAC, and the Pico. And then one of the most annoying parts of all of this was actually the wiring, and you can't really see it because it's hidden under this white bar here. But under that white bar, what I had to do, because I couldn't find USB 3.0 ribbon cables, which you need USB 3.0 because when these things are spinning out the CDs, they draw about 1.5 amps, and the USB 2.0 off the Raspberry Pi just didn't have enough current to actually power the player. So you need USB 3.0 and it was a nightmare to run these cables through, but you can kind of see as I spin this right in the middle there, these cables pop out. But basically in these white things is an entire 3D printed track, and then there's this little tiny carriage that rides on the inside of it in bearings and slides along this, and it's being pulled this way through an elastic band on a pulley system that goes all the way through here, and it's just pulling that carriage back this way to tension this wire back. So you can see as I push this, it's popping out over here, but it's being pulled in, and if that little tensioner system wasn't in there, then this would just shoot out and then come up here and destroy everything and get tangled up. So that part took like most of the time, like months I spent trying to solve that wiring problem. I waited a long time trying to get 3.0 ribbon cables from China, but then some of them were 2.0, and then some of them were ribbon cables covered in hard rubber so they could barely bend. So I just ended up going with some like normal USB 3.0 braided cable. I think it's an anchor cable in there. And you can see there's actually two wires going through there. So there's this little black wire and there's this gray braided wire. The black wire, and I'll get this demo player back out, actually goes to a little transistor that goes over the switch to detect when these are closed, because these are actually pretty stupid devices, and basically they just start playing when a button is pressed and stop playing when it's not pressed, and that's just controlled by the player being pushed in or out. And the best way I found to just trigger that is to just get a little PNP transistor and then run it all the way back to the Raspberry Pi, and then right there in that port, it just toggles on and off the player to activate it. So that's honestly about it. In terms of materials, a lot of it was just like finding these 1" by 1/2" long square extrusions for here and here. And along the sides, there's a bunch of square extrusions. And then just covering it all up with a bunch of 3D prints. And yeah, it wasn't too complicated to do. It took a long time to get done. But if you have any questions about specific parts of it, I'll try my best to answer them quickly down in the comments. And yeah, just let me know. And more stuff coming. Here's a little sneak peek at what I'm working on now. I'm trying to build a kind of replica, kind of thing inspired by the Teenage Engineering TP7. So here's a little BLDC motor, motor controller, magnetic encoder below there, and then a Pico, and then a little DAC unit. But that is coming. Hopefully maybe one day soon. We'll see. And I guess actually one last thing, these custom CDs, and I have a bunch of them now that I've made. I printed them all. I got this super cheap Bravo XRP off eBay for a couple $100 broken, and I fixed it. And this will burn the CDs and then print graphics on them. So I just ordered these inkjet printable CDs, burn songs, quote legally, unquote, and then I printed some cool graphics I just designed in Photoshop on. And yeah, that's really how this all came together. So again, let me know if you have any questions, and thanks for watching. See you guys.